So we could use this concept of taking the derivative of an inverse to extend it to finding derivatives of inverse trig functions. Now, ultimately, you just need to really memorize the derivative of sine inverse, the derivative of tangent inverse, and the derivative of secant inverse. The reason why I tell you to only memorize those is because these derivative of cosine, cotangent, and cosecant are all just the negative of those above. And also, sine inverse, tangent inverse, and secant inverse are the most common ones that you see. So I want to go ahead and prove this one so you can see how these properties are derived, but ultimately you just need to memorize these, and they are in your Quizlet that you'll get to memorize of derivatives. So let's derive this one. So let's say y equals sine inverse of x, and we want to find this derivative. Now, we don't know how to find the derivative of the inverse, so I'll take sine of both sides. And when I take sine of sine inverse, it cancels out. So now we have sine y equals x. So now I can take the derivative implicitly. The derivative of sine y is cosine y multiplied by dy dx, which is y prime, equals 1. So now y prime equals 1 over cosine y. So now what is cosine y? So remember from this step that we have sine y equals x over 1. So if I draw a triangle with theta, this is my opposite side and this is my hypotenuse. So my opposite side is x and my hypotenuse is 1. If I do the Pythagorean theorem, this side is 1 minus x squared. So now this is my adjacent side. So cosine is adjacent over hypotenuse, which is square root 1 minus x squared. So we have just proven that the derivative of sine inverse is 1 over the square root of 1 minus x squared. And the other 5 identities are all proven in a similar fashion.